Virtual immortality. I'm the old guy at Ramblr, 49 years old. AI for the physical world. Roman and I, we have a very special history. We built our previous company, Meteo, together. It's an augmented reality company. We did the middleware for augmented reality, mostly egocentric tracking, object detection before LLMs and before generative AI. Sold the business to Apple in 2015. Can't talk about it, can't comment, can't confirm, but we stayed in the augmented reality space inside Apple. And then in 2019, my good friend Roman, who I shared a hotel room with last night, called, a very memorable experience, by the way, called and said, let's do what we did at Meteo, which is effectively middleware for augmented reality with machine learning. This is how we started Ramblr. Ramblr is now a startup, like before, 25 people based in San Francisco, Munich, and Dresden. And what we are specializing on is building contextual AI for augmented reality. Why does this matter? Quite simply, augmented and virtual reality always had a huge content problem. And now, with the advent of LLMs and generative AI, this content problem, in our view, goes away entirely. So we're starting now to take this power, LLMs, visual sensors, also rotational sensors, and are building a platform where you can deploy massively LLMs for content generation and also for contextual understanding of the real environment. And with that, Roman, I hope you slept well. Take us away.
Thanks, Thomas. Well, it's great to be here. It's AWE. I think we've been going for, 15 years? So it's exciting because this is the first time we actually show what we do at Ramblr in a public setting. We are bringing AI to the physical world. And we believe that augmented reality or mixed reality devices are kind of the perfect hardware to do that. It's all about the perspective. It's the human perspective that we take and that we learn to understand. And it provides us with, it's basically unlimited what you really can do with that the moment you wrap your head around it. Anyway, so we're at a very interesting moment where hardware is making a lot of progress. We see that some of the more consumer-focused devices are kind of bringing augmented reality to the mainstream, and we are heading towards a point where these mixed reality and augmented reality devices are colliding with generative AI. And I think it's going to be such a powerful moment for the entire industry because what we've seen over the last couple of years is, first of all, generative AI is going through the speed it's developing, it's unbelievable. And secondly, it's so powerful. It's so extremely powerful when it comes to its reasoning skills if you provide it the right information. And that's kind of what we're going to focus on today. But before we get there, let's just see where we are in the consumer space.
Look and tell me about the history of this model.
So this is Mark Zuckerberg prompting the Ray-Ban 3, essentially asking what he's seeing, right? The Ray-Ban 3 probably takes a single image or multiple images, I don't know exactly, plus location data, and it can provide him with rich information about where he is at that very moment. And that's quite powerful, but we believe there's something missing, and that is spatial temporal context. We believe that it's so much more powerful if you truly understand what the person has done in the past in order to be able to provide an accurate answer what he's supposed to do next. And what you see here is it's basically called contextual AI, but let's not get into the nomenclature. On a higher level, what comes in is multimodal video and sensor data. Then we try to understand video on a very granular level, and we come to that later on. And then we provide that context to an AI assistant or an LLM in order to answer your prompt accurately. So let's define context a little bit, because that's actually a pretty complex beast. And I kind of divvied it up into higher level context and more detailed context. And it's very much focused on what is dubbed the egocentric perspective, meaning the first person view. So on a higher level, we want to understand what is the intent of the person, because that gives us a lot of information about, what is he actually trying to accomplish. Then we want to understand in which environment he or she is, right? Because that, again, is some really important information that helps to determine what actually the next logical step is. We want to understand actions, as in what has already been done in the past, so that we can predict more accurately what we are supposed to do in the future. And then on a very detailed level, like on an object level, we want to understand which objects are around us. We want to, and not just like what we see today is reconstructing basically occlusion maps. We really want to also classify these objects. We want to know, is it a plate or is it a frisbee? That makes a huge difference, certainly. We want to track these objects over time. We want to understand what the relations are between those objects. We want to understand, which is more of a research term, but a point of no return, meaning just imagine you have a coffee machine. The system sees it as one object, but eventually you take out the glass can. So now you have two objects, right? Which is for humans, it's pretty straightforward. For machines, this is a very challenging scenario. And then, of course, we also want to understand the object properties. That's very important in more industrial focus cases. And then we go all the way down to the human level, where it's all about attention, where we can use gaze tracking to really understand what is he or she really focusing on, right? Is he considering using object A or object B? We understand hand-object interaction, and of course, voice and audio. And that's a lot. Like asking a system to understand that much information about the world, and then in an ideal case, we want this all to happen in real time, that's a lot. But it's a very exciting and complex problem to solve. But how does this, let's go just one step deeper here. How does this all work, right? So again, on the input side, we have a first-person camera stream. Could be an AR device, could be a mixed reality device, but it can also just be a camera that is mounted on a human, like think of the AI pin from Humane. We want to extract that context from the sensor stream we get in. We store that context in a RAG database. That's, I don't know to what extent you're familiar with the more language model world, but that's region augmentation generation. It's basically one technique to force LLMs to generate an answer from an existing knowledge base and kind of avoid it to hallucinate and provide more accurate information. That context database is essentially storing all the things the person has, like all the activities the person has performed, all the information that we have extracted from video, but also, like for instance, in a more industrial setting, step-by-step instructions, like all the things that are already there, that already exist at these companies. And we can provide all that as part of context to LLMs. But the really interesting thing is, it goes both ways. So the LLM can also request context. Like let's say a prompt comes in, and it's about, I'm making pasta. Like, what am I supposed to do next? And then the model tells you, well, you haven't added salt to the water yet, to the pasta water, right? And for that, we need to understand, first of all, that salt is actually part of that workflow, right? That doesn't come natural necessarily. And that's kind of what I mean with existing understanding, and then we complement that with that real-world context to enable these LLMs to provide really accurate answers that are relevant for your prompt. And you don't have to engage into a discussion where the model actually asks you, so tell me, what have you done before? And then you list all the things, and then eventually it's like, okay, why don't you do X? We don't want that. It needs to be more natural. the interaction. And for that, the model needs to understand context. So what does that look like in a more industrial setting? What you see on the left is essentially our system and what our system sees. And I'll show you a demo later on. I will give it a try. I hope my tethering is strong enough. So that is on a very detailed level. And on the right side, you see us using actually ChatGPT Omni together with the context that we provide to ChatGPT Omni, and we prompt it. And I can show you that live in a little bit, but you can see that the level of detail that we can get from these models, even though ChatGPT Omni has never seen any of that data. Like that is not part, like what you see here is not part of the training set. I'm pretty sure it's not part of the training set that ChatGPT was trained on, because it's kind of very obscure data. It's not the normal distribution of data you find on the internet. Yet, it is extremely strong at generalizing if you give it the right context. So the challenge really comes down to how can we extract that rich context and then leverage the power of these models and their generalization skills in order to really move this to the next level. We at Ramblr, we have a very human-centric perspective. As far as we know, we're we're one of the very few companies who are really pushing hard in that space. The other companies, of course, Meta, who has a ton of research projects going on and is also publishing very rich data sets. If you're interested, you should look into it. It's called Ego 4D. And there are other research, kind of in the research community, other very powerful data sets like Epic Kitchens. Anyway, from our perspective, we are more focused on the industrial space. That's kind of our background. Thomas keeps on saying he's an engineer, a mechanical engineer. And that's kind of where we're coming from. That's very similar to what we did at Meteo. But this time, we really want to empower the human. We want to basically build a system that is your best coworker, that has the same perspective that you have, understands the world the same way you understand the world, and you can just ask the system any question, or the system can even prompt you, can even ping you proactively if you deviate from the workflow in a way that it's significant. I'm going to show you two examples how this is deployed in the real world. One of them is with BASF, a company in the chemical industry, and they use our system to guide their quality control process. So they, of course, have very high requirements on quality. This is a flange assembly process. Trust me, before we started working with them, I wasn't really an expert at flanges. At this point, I am. What you saw there, the points, that's actually a point tracker that tracks these objects throughout the video, and it can actually recover really well. So even if the object is out of the field of view and it comes back in, we can recover and track it again. And what you see now are more the richer masks. That is basically what the system is trained on. And what we are trying to accomplish here is we really want to understand on a granular level if the operator is deviating from a very specific workflow. Because if they do, BASF knows that it leads to issues in the future, which could then lead to shutdowns of the plant, etc. And there's a huge cost savings potential for them. And for us, it was an extremely challenging project. Everyone who's ever worked in computer vision knows that low light, reflective objects, a lot of motion, and no text and no color differences essentially is very challenging. So it really was something where we had to work hard to get this to work. But this is going to be deployed hopefully very soon on a very large scale. Then on a more AI assistant side, we partnered with a company called Apprentice, where we are supporting lab operators. And essentially,
10
this
milliliter
is
sample from vial 3.
I'm going to let it run for a second, and then I explain what's going on.
5 milliliter sample placed into test 3. 5 milliliter sample placed into test 4. Step 2, complete. AI, what is the next step in the procedure?
Sending you the next step in the procedure. To prepare step 3 for the procedure, begin by filling wells 1 through 6 with media from vial 1.
Yeah, so what you saw here is basically truly multimodal. So we use both. We use image and we use the voice signal from the operator. And we combine that to extract these key moments from video, right? And that essentially helps us then to understand where the operator is in the process in order to be able to tell him what he's supposed to do next. So it's a really exciting project we worked on, and it's still ongoing. And one of the problems we solve with that is not just informing the operator. We can also automatically document the steps the operator has performed, because currently these lab operators actually have to spend a whole lot of time like documenting every single step of their experiment, either experiment or even in the production process. So it's a huge time save for them. And all it takes is basically a camera that takes the first person perspective to get this off the ground. So where do we come in? As a company, what are we building? What are we providing? We are actually a platform that we want to enable each and every one of you to bring this rich contextual information to your application, right? That is our goal as a company. For that, you can sign up to our program. We have an early adopter program, and you can also try our playground. I will show you some of the examples in a second that are in our playground. Oops, sorry. And if we look at it from a higher level, there's 3 core components. One is the data engine. So a lot of what we do is essentially working with data to train these very sophisticated models. We do have pre-trained foundation models for pretty much every significant model you need in the chain, but you can also bring your own models if you want to. And our data engine is kind of at the core of everything, because the use cases we're working with, there's usually not millions of hours of data available so that you can train unsupervised. So we need to have a certain level of supervised training. And it's also important because, in our world, 80% accuracy is not acceptable. It needs to be in the high 90s. And for that, you need a more supervised approach, and you need really rich validation data sets to make sure that you actually have an understanding how well your model performs in the real world. Then there's video understanding. Those are models that we trained. This is, after we've fine-tuned them to your specific domain, or you can fine-tune them to your specific domain, the idea is that they can extract that rich context from video. And then on the intelligent AI assistant side, we are entirely agnostic. You can use any LLM that you would like. There is a little bit of work on the prompt engineering side, but that's just the way it is these days. But we also have smaller models that are a lot faster and more targeted. They are vision language models that you can deploy in your system. And I wanted to show you quickly what that looks like. Let me just see if this works. Nope. How do I share my screen? Can you share my desktop, or is this something Oh, it does this. Oh, hold on. Give me 1 second. Then all right, got it. apologies for that. This is the problem with live demos, I guess. I did. It's not sharing the whole screen. How did you start sharing it earlier? Because I just need to share the other window.
Which one you got?
The Chrome.
Where's it at?
Here. No, it's not.
Didn't go over. Oh, let me go to. Hang on. Bring it back.
I got it.
Can't see it all. There we go. Let's just go to your display settings. Let's just go. Let's do mirror.
All right, thank you. So this is our tool. What you see here is essentially the video data coming in. And then just to give you an idea, so these are activity annotations. Those are generated automatically. They're describing on a very detailed level what the operator is actually doing, what is performing. And then we can also show these relations. You saw that earlier in the video. On a very detailed level, the nodes describe the objects, and then the edges describe the relation of the objects. And this is fed to the LLM as part of the context we provide, which enables it to really give us these highly accurate answers. So what does the system see? Those are the objects in the scene. Let me just quickly turn this on. So this is basically the perspective of the system. And this is now a training data set. In the on the inferencing side, what we do is not as rich with regards to the details that you see here. There we are more relying on what you saw earlier, the point tracking approach, and extract that level of context from there. And then with all that, we can also prompt our system, which decided now this is a good time for an error to occur. There we go. Let me just So this is live. Cross your fingers. There we go. That's how fast it is. And this is highly detailed information, so it tells me exactly where certain things occur in the video. And I can ask open-ended questions like, did the operator make any mistakes? And it's using the context to tell you that it's very long, so we haven't forced it to keep it short. So you can tell it has a strong opinion about what's going on. And it did find a potential mistake. Oh no, it didn't. There are no obvious mistakes in the handling of the equipment. The thing is, we haven't really fine-tuned that. As I said, this is GPT Omni out of the box, just with a little bit of prompt engineering in our context. But it's capable of really understanding these videos on a level that it can reason on open-ended questions, which is, in my opinion, absolutely phenomenal. And we want to be the platform that people are using to bring this really to their applications, that power of AI. All right, I guess the music tells me that this is over.
We're done.
That I'm
Thank you very much.